Okay, so we're back here for part 2. Now you're probably telling yourself, you know, everything that we just did in part 1, I've done that before, I've already learned that. Well, we need to know how to plot points, and we need to know how to state the coordinates to write the XY ordered pair, because in Algebra 1 we start looking at what's called functions and relations. So in the second section here, we're going to look at what's called graphing relations. A relation is a set of x and y values, or a set of ordered pairs. And we're going to add a little vocabulary here. Another name, so we have x and y for an ordered pair, but another name for the x values is the domain. That is all the x values. And then the y is what we call the range. Domain and range. Now we're going to use those a lot. So you need to know the domain, hey, that's just x. That's all we're talking about. And the range is just the y values. So number 3 says, find the range values. Now I'm going to put the letter y next to that. For, now this is an equation, y equals 2x plus 3. If the domain, that is the x values, is, this bracket here is a set. So is the set of values -3, -2, 0, 1, and 2. Now this gets us into what we call functions. That's going to be our next topic. But the idea is that if I have an equation, and if I substitute a number for x, I can evaluate this, and what that gives me is a number for y. So a relation is a set of ordered pairs, a set of x and y values. Now they're telling us that the domain, we have 5 x values we're going to use. And you'll notice on the table here, -3, -2, 0, 1, and 2. This is our domain. What we need to fill in here is the range. We need to find what the y values are. Well, the way we do that is we take each x value and we substitute it into the equation. So I know there's not a lot of space, but I'll do it on the side here. We get y equals 2 times x. Well, the x value is -3, and then plus 3. Now, if we evaluate that, we get -6 plus 3, and that adds up to -3. That's the y value. Now, if I do it again, now if x is -2, now I substitute -2 into this. So y equals 2 times x plus 3. The x value is -2. That's -4 plus 3. And -4 plus 3 is -1. See, what we're doing here is we want to find ordered pairs, because then we can graph them and we can look at this equation. We can look at the relation and decide if there's a pattern to it. 0 is always an easy number to substitute because y equals 2 times 0 plus 3. Anything times 0 is 0, so that's gone. All we have is 3 plus 3. Y equals 2 times 1 plus 3, and then y equals 2 times 2 plus 3. So what we're doing, we're taking each x value, each domain value, we are substituting into this equation, and we're finding the y values. This would be 2 plus 3, which is 5, and this is 4 plus 3, which is 7. And now the cool thing is, we have a set of ordered pairs. Okay, I could even use parentheses here. And I can plot this. -3, -3 is left 3, down 3. -2, -1 is left 2 and down 1. 0, 3, we don't move left to right, we just go up 3. 1, 5, right 1, up 5. Now 2, 7, we go right 2, up 7, but this gets me 6. I'm going to go up one more place. I'm going to estimate. And notice that this is a relationship. It looks like a line. Now, we're not going to connect. I'm only graphing these points. It doesn't say to graph the line itself, okay? But a line has an infinite number of points. These are 5 ordered pairs, but if you put more x values in, you would get more y values. So the value of this is when we're graphing, if you ever need to look at it, if you need to graph it, and they give you the equation, pick numbers for x and substitute and get the y values. And if you have enough points, you can graph it and you can look at it and see a pattern. All right, let's take number 4. So try this one yourself here. Make a table of values. Here's the table. Graph the equation. Now it's y equals -1/3 times x minus 1. If the domain, remember domain is the x's, -6, -3, 0, 3, 6. So I'm going to fill those numbers in. They give us that. They do not give us the y values, but we can find them by taking the x and substituting into the equation. Now on the side, what I'm going to do, I've got y equals, and then this is the right side of the equation. Over here, I'm going to set up -1/3 times x minus 1. I'm going to do this 5 times. Because we have 5 values that we need to evaluate. Substitute. So the first x value, the first domain value is -6. And then -3, 0, 3, 6. Now you might be thinking, why did I choose these? Why not go with, -3, -2, 0, 1, 2? Why not do that? Well, what I'm doing, I'm kind of looking ahead and saying, hey, you know what? I have to multiply the x by a fraction. So if I can come up with values that will make these integers, that would be really nice. And what I mean is this. When we do -1/3 times -6, I can write that over 1. A negative times a negative is +6. And then this would be 3 in the denominator. 6 divided by 3 is 2. So that's really 2 minus 1, which is 1. So when x is -6, the y value is +1. When I multiply this, I get +3/3, which is 1. Subtract 1 is 0. The y value is 0. Anything times 0 is 0. 0 minus 1 is -1. -1/3 times 3. This, okay, here's 3/1. One of the things with fractions, you can divide first if you want. I can do 3 divided by 3, which reduces to 1. And this whole thing is -1 minus 1. And -1 subtract 1 is -2. And the last one, -1/3 times 6, is -6 divided by 3, -2 minus 1, which is -3. And now we can plot. So again, it's x comma y, left 6, -6, up 1. -3 comma 0. Now the 0 is the y value. We don't move up or down, so I'm on this x-axis. 0, -1. We don't move left or right, we just go down. You notice the pattern here. 3, -2. So we go right 3, down 2, and then right 6, and -3 is down 3. And look at that. So that's another linear relationship. Okay, both of these are what we call linear because they're in a line. They make a line pattern. All right, we got one more here, number 5. And this equation, I can tell you at the beginning here, this is going to be different. First of all, it uses f of x. Now this may be new to you. What that means is a function. It's actually the same thing as an equation. F of x is another way of writing y equals. This is the same thing as y. And you'll say, you know what, that looks a lot more confusing to me. But if you can remember that a function is the same thing as an equation, the domain is the x's, but what I get out of that is the y values. So now, we have an x squared here. as well. So that's going to change the shape of our graph. It's not going to be linear this time, and you'll see a different shape. Here's our domain. They're telling us the x's are -3, -1, 0, 1, 3. So how do we graph the relation? Well, we need to find the y values first. We need the range. So we're going to take -3, and it's y equals. You don't need the y equals. I didn't write it in the last example. I'm just evaluating the right side of this function or equation. It's x squared minus 4. So let me set up my parentheses. So each one of these is the x value squared and then subtract 4. So to evaluate, we're going to substitute, starting with -3. Now be careful here. When you square a negative -3 times a -3 is a positive 9. Minus 4 gives us 5. -1 times -1 is 1. Minus 4, that's -3. 0 squared is just 0. Subtract 4 is -4. 1 squared is 1. Minus 4, that's -3. And 3 squared is 9. Minus 4, and that gives us positive 5. Okay, so let's check this one out here. We're going to graph -3, 5. So start at 0, 0. We go left 3, up 5. -1, -3. So we go left 1, down 3. 0, -4. So that means we just go down. The x value was 0, so we don't move left or right. We just go -4 for y. 1 comma -3 is right 1, down 3. And 3, 5 is right 3, up 5. Now that is definitely not a linear shape. This is not a line anymore. Actually, what this is, we'll get into this later on in Algebra 1, this is what we call a parabola. And that's a different type of shape. It is a curve. And that is the end of part 2.